Can I save these documents on a dying machine from oblivion? First, a confession. No, I didn't do the backups I should have. Second, the situation. I have a Dell XPS 9550 with a solid-state disk running Fedora 25. I was working on a file and tried to save it when I was told I was trying to save to a read-only file system. Turns out my file system is read-only now and there are I/O errors all over the place. I was able to save some of the files by emailing them to myself through an open web browser, but that crashed and I'm unable to relaunch it. But I still have files of interest open in an editor. I can't seem to save the files anywhere, but I can copy their contents. If only I could find a way to exfiltrate the file contents, I could save myself months of work. But there are some horrible limitations. I attempted to insert a USB drive, but no device appears to represent it, and the mount command dies with a seg fault. I can attempt to SSH to another computer, but I get bus error and it dies. Ping, neast, ifconfig, none of these work. But I do have them in less and ls and can spawn new bash instances. No links, no Firefox, no Google Chrome. There's no DVD drive. Basically it seems my SSD has died. Or maybe the whole motherboard. I have documents of great value still in memory, I have an IP address and network connection, I can run a few random commands and have 3,500 more on the path that I could try. cat and gcc seem to work. I can write to files in /tmp. I have a running IPython instance that still seems to work. So, what I've tried so far has failed. But I feel like there are still 1,000 possibilities. What am I not considering? How could I possibly get these files off of my dying computer? There must be a way. Update, new stuff. I lost my network connection due to my own stupidity. I wrote a Python script to replace CP and CPR. Unless I find some way to create a /dev entry for the SD card, or for USB drives, then my best bets for getting data out seem to be the screen and possibly the speaker/audio cable. I'm writing a script to try reading files and output which ones are readable. Suggestions still very welcome. Update 2, newer stuff. On the dying computer I wrote a Python script that will read a file bit by bit and try to convey those bits by flashing the screen one color or another. Right now it's trying to do a 2-bit code where red, green, blue, and white all represent a 2-bit pair. This isn't working that well, though, so I might just switch to 2 colors and do 1 bit at a time. On my other laptop, the trusty old ThinkPad that I gave up for this hot new XPS, I wrote a script that reads from the webcam using the OpenCV Python library. The idea is to have it decode the code sent by the other computer. The trouble is that the frame rate from the camera is something like 15 frames per second, which means if I had a perfect, errorless transfer my maximum data rate would be 30 bits per second, i.e. 225 bytes per second. That's 324K per day. On the dying XPS I can use tar to pack the desired files into a single archive, which is 1.7 MB. Unfortunately, zip, zip2, XZ, LZOP and whatever compression utilities are unavailable. But using Python's lib module I can compress this file down to 820 kilobits. Given that size, I could probably get this thing sent over in a couple of days. Because this transfer method will likely be very error prone, I'm going to implement hamming codes on the XPS to add some error correction as I transmit the data. Likely there will be complications because that's what happens, but at least it seems somehow feasible to get this data out. Since this is still a pretty sucky way of sending data, I looked more into USB serial drivers. The modules I've tried to load, USB serial simple, USB debug, safe serial, give IO errors. I don't think it's built into the kernel, either, because there are no /dev/TIA's devices present. Thanks for everyone's suggestions thus far. I know this isn't even a well-defined question since you guys don't know in advance which programs/files can be read or not. Still open to better suggestions than this video approach. Update 3, newest stuff. I got a PS3i webcam and, after disabling its automatic gain and exposure, am successfully reading data off of the XPS, albeit at an errorful 1 byte per second. This is a great success, the first data exfiltrated. But the rate is too slow to get my 820 kilobits out in any sort of reasonable time, and the error rate is too high. The problem is that writing to the terminal is too slow. The screen updates aren't anything like instantaneous, thanks, I think, to the slowness of the IRX terminal emulator that I have access to. I discovered that I have access to a Rust compiler on the XPS. I rewrote the transmission script using Rust to see if that would improve the terminal refresh speed, but it didn't help. Because I'm unlikely to be able to increase the frame rate, I'll have to try to increase how much data I get per frame. My current approach looks something like this. The right half is still a clock signal, flashing on and off to mark the arrival of new frames. But the left is now a grid where each cell is marked by a red square in the corner, and then the green cell to the right and down from the red square is flashed on and off to indicate a bit. The red squares should let the receiving computer calibrate where the cells are located. I haven't got any data across this way yet, but it's what I'm working on. Someone suggested that I look into writing QR codes instead of these ad hoc color patterns. I'm going to look into that, too, and perhaps implement that instead of this grid approach. The error correction would be a nice win, as well as being able to use standard libraries to decode. I learned that I have access to LiveSound, the AlsaSound library, but not to the header files associated with it, alsa/soundlib.h, or whatever. If anyone knows how to make use of a shared library without the headers, or can help me write just the right header to let me produce audio output, then I could have an audio-based way of getting the files out. Alternately, if someone could help me manipulate the USB devices without access to live USB, then maybe I could do something with that. Moving forward. Update 4, audio output produced. User Francesco Naferi has done some great work helping me utilize the ALSA library mentioned in the previous update. The C compiler had a problem, but using the Rust compiler I was able to use the fee to call directly into LiveSound. I've now played a bunch of my data over audio and it sounds like music to my ears. Still need to get a real communication channel established, but I'm feeling very hopeful. At this point my job is basically to implement a modem, so if anybody has any guidance on good ways to do that, I'm all ears. Ideally modulation that's easy to implement by hand and demodulation for which there's an existing library I can use. Since this can go directly over an audio cable and not through the phone network, theoretically we can do much better than 56 kilobits per second or whatever the standard was back in the day, but in practice who knows what we'll get. Thanks to everybody following along here and at /r/tech support McCheever and at /r/Rust contributing so many excellent suggestions. Going to get this modem implemented soon and then I'll finish this up with an epilogue. I think I might put my code up somewhere for other desperate folks to make use of in the future, maybe even a repository of weird exfiltration tools that are easy to type into a dying machine by hand. We'll see what happens. Update 5. It took me a long time wrestling with also in my cheap StarTech USB audio capture device, no built-in line in on the receiving laptop, and many false starts trying to roll my own transmission protocol. But finally, under the advice of some ham radio enthusiast friends of mine, I implemented the reline protocol running at 150 baud, which in practice gives me maybe about 10 bytes per second. It's not super fast, but it's fairly reliable. And I'm very nearly done transferring my 820 kilobits file, verified using CRC32 checksums, using the CRC32 functionality from Python's lib module, which I have access to. So I'm declaring victory, and want to give my thanks once again. I'll spend some more time finding further files that are readable and which I can transfer, but the foundation is in place. It's been fun working with you all. Final update. On the dying machine. On the rescue machine. Smile.
Here's an example LibraSound program with just enough definitions to get basic 2-channel 44.1K wave output going without the headers. Edit. I'm actually not sure if straight up dumping the data as wave would work, as noise when recording could easily damage it, but you can probably do something like a sine wave of bits at high frequency, which is more reliable. Edit 2. If aplay is present and works, you can also use that and just write a program that output raw audio and pipe it into aplay or anything that can play audio. Edit 3. Modified it to not use any headers at all. If LibraSound doesn't compile, at l/path/where/LibraSound/is/ located.
Is your HDMI or any other display output working? If so, you can use a screen capture device to record it as video and process later, thus not being limited by your webcam's frame rate.
How about you hex encode your data and output it page per page to the terminal? You can add a prefix with the offset in the binary so that you can easily regenerate a page, for manual correction. Then on a different computer use some OCR software to scan the pages. 80 by 25 terminal would yield 1000 bytes per page, minus some space for the prefix. So in roughly 1000 pages you could get out your data. Even at 1 page per second, that's less than 20 minutes. Hex encoding is easy to write and also provides a raw form of error correction. There are only 16 valid symbols.
Can you set up a network connection? SSH might be a bit too much, but if you can use Netcat on 2 machines you might be able to transfer data. One in sending mode, one in listening mode. If all you need to do is transfer text, then this could be a solution. Edit, never mind, just read that you lost your network connection as well.
If you want to support the channel, please consider subscribing.